Good morning, this is Dr. Turner for Fundamental Mathematics. Today we're going to be looking at 9.3. 9.3 is looking at our quotient rule. 9.2 was product, which involved multiplication. Now we're looking at our quotient rule, which involves division. So with your quotient rule, it's going to look very similar to what we just saw with product rule, but this one is division, as the name might imply. And with the quotient rule, the rule is a to the m divided by a to the n is equal to a to the m minus n. Again, depending on the text that you're looking at, that formula might look a little bit different. It might use different variables, but the setup is the same. And similarly, the textbook definition is going to be a little bit more wordy, but essentially what this translates to is if you are dividing and the bases are the same, you're going to keep the base and subtract the exponent. So just like with 9.2 and 9.3, this could involve variables, or it could involve integers, or it could involve fractions, decimals. The rule is the same. If I have x to the 6th power divided by x to the 3rd power, my bases are the same. They're both x's. The rule is keep the base and subtract the exponents. Now here, just like we did with 9.2, if I forget the rule, there is a way to solve this by writing out the expanded form. X to the 6th would imply that I'm doing x times itself 6 times. X cubed, x times itself 3 times. We can cancel out 3 pairs of x's, which leaves me with 3 x's on top, or x cubed, like so. So as always, there's more than one way to do this. And the rule is going to be the same if these are integers. So 9 to the 5th power divided by 9 to the 3rd power. 5 minus 3 gives me 9 squared. Number 3, 6 to the 8th power divided by 6 to the 3rd power gives me 6 to the 5th power. Same is going to be true no matter what it is. So it could be a fraction. 4/7 to the 10th power divided by 4/7 to the 3rd power. As long as the bases are the same, you keep the base and subtract the exponents, 10 minus 3. Depending on the book or the context, you might be asked to actually evaluate these expressions. Right now, we're just showing that we understand the rules of exponents. And for my examples 1 through 4 here, I always put the exponent, a larger exponent on top in the numerator than I did in the denominator. Now, that doesn't always have to be the case. So for instance, x squared divided by x to the 7th. Well, 2 minus 7, that would give me x to the negative 5th power. Well, what did negative exponents do? That's going to be another video for 9.5, but just be aware that even if the exponent in the numerator is higher than the exponent in the denominator, your quotient rule still applies. That's it for 7.3. If you guys have any questions, please reach out to me. Otherwise, have a good day, and I will talk to you soon. Bye.